Look around your room. For 10,000 years, human civilization built everything from one organic material: wood. We destroy 15 billion trees every year to keep up, making it feel irreplaceable. But Chinese scientists just changed everything. They engineered a synthetic, biomimetic breakthrough using agricultural waste and polymer bonding. It does not just mimic wood, it completely outperforms it. This material is entirely fireproof, waterproof, and costs a fraction of the price, terrifying global timber giants. Would you live in a home built from synthetic crop waste? Let me know below and subscribe for more deep tech videos here. To understand why this new discovery is such a massive deal, you first have to appreciate why timber has held an absolute monopoly on human construction for thousands of years. It's not just because trees grow out of the ground for free. It's because wood is genuinely one of the most mechanically brilliant materials ever created. On a microscopic level, it's a masterpiece of natural engineering. Wood is made of long cellulose fibers bound together by a rigid organic polymer called lignin. This exact blueprint gives it a phenomenal strength-to-weight ratio. It can bear immense vertical loads while remaining flexible enough to bend during high winds or minor earthquakes. It acts as a natural carbon sink, provides exceptional insulation, and can be shaped with basic hand tools. For most of human history, nothing else came close, but wood has a massive built-in structural flaw: biology. Because it's organic, it rots. It warps when it gets wet. It treats fire as fuel. And worse, it takes decades for a tree to mature enough to be harvested for high-grade structural lumber. Think about the sheer scale of modern development. China alone, in its massive push for urbanization over the last 2 decades, consumed more raw timber and building materials than Western Europe used in an entire century. The planet simply can't grow trees fast enough to keep up with that velocity. For years, scientists tried to create alternatives, like wood plastic composites and fiber cement boards, but they failed fundamentally. They were either too heavy, structurally weak under tension, toxic to recycle, or too expensive to compete with a raw log. The question left for engineers was simple. What if the mistake wasn't trying to copy what wood looks like, but failing to replicate how it behaves at a molecular level? To understand this breakthrough, you have to look at how a tree actually grows. Natural wood is basically a massive network of microscopic tubes, all aligned in a single direction. That alignment is exactly why a log is incredibly strong along the grain, but splits wide open if you hit it across the grain. A research team at the Chinese Academy of Forestry decided to completely hack this organic geometry. Instead of cutting down old forests, they harvested agricultural waste, leftover wheat straw, hemp, and processing scraps from fast-growing bamboo. They stripped this waste down to its raw cellulose fibers. Normally, when factories make synthetic boards, they just mix loose fibers with glue and randomly press them together. It's weak. The Chinese team did something radical. They passed a liquefied fiber slurry through a specialized directional freezing process. As the water froze, it forced the raw fibers into perfectly straight, parallel channels, perfectly mirroring the microscopic grain of a 200-year-old oak tree. Next, they infused this perfect matrix with a biosourced resin and blasted it with high-pressure steam. Under immense heat, the resin didn't just coat the fibers, it cross-linked with them chemically, simulating millions of years of natural petrification in mere hours. The result? The material's internal gaps dropped by over 80%. This matters because those microscopic gaps are where every single wood problem begins. It's where water seeps in to cause rot, where termites crawl, and where oxygen hides to feed a fire. By crushing those voids, they eliminated wood's greatest weaknesses in one move. Laboratory tests showed a tensile strength 120% higher than hardwood and a Class A fire rating. It literally refuses to hold a flame. The best part? It locks up agricultural carbon that would otherwise be burned in fields. While scientists were busy publishing papers on this biomimetic wood breakthrough, a completely different disruption was quietly happening right next to them. And this one didn't just rethink what we build with, it completely rewrote how fast a building can be put together. It's called hyper-compressed bamboo fiber tooling, and advanced infrastructure firms in southern China are already scaling it up. Think about traditional timber. It's slow. You need heavy carpentry, precise kiln drying, and weeks of on-site prep just to stop the wood from warping. This new method skips all of that by treating engineered biowood like a high-tech polymer. The material is extruded straight out of the machine into massive, interlocking tongue-and-groove panels. They even stamp internal channels for electrical wiring and insulation right into the core during the press. But here is the real game changer: how it handles environmental stress. In humid tropical zones or coastal climates, normal wood is a maintenance nightmare. It warps, rots, and needs constant chemical sprays that leak into the soil. This material? It doesn't react to moisture at all. In testing chambers, even after being fully submerged in salt water for a year, its structural variance was less than a fraction of a millimeter. When you fuse raw strength with lightning-fast assembly, the economic impact shifts entirely. That undeniable math is exactly why global markets are scrambling to lock down the rights. In the global commodities market, sentiment doesn't matter. Idealism doesn't alter supply chains. Only math does. Normally, changing international building codes takes decades. Why? Because when structural materials fail, the cost is measured in human lives. Yet right now, Western markets are completely skipping the usual hesitation. Look at the receipts. Trade data confirms a massive spike in export volumes of these advanced biocomposites shipping straight out of Ningbo, China, to major distribution networks across Germany, Japan, and the UK. Major Scandinavian furniture giants and European prefab developers have already signed long-term procurement deals to integrate these synthetic beams. Why the sudden rush? It isn't because these corporations suddenly grew a conscience. It's because in regions with strict carbon taxes, swapping old-growth timber for certified carbon-negative agricultural waste slashes regulatory costs overnight. If we replaced just 25% of global timber demand with this compressed biomaterial, we would save roughly 3.7 billion trees a year. That offsets more carbon than taking every single diesel truck in North America off the road permanently. But let's be entirely honest about the roadblocks. The traditional timber industry is backed by massive political infrastructure, sawmills, and deep consumer habits. People simply like the smell of real wood. Plus, manufacturing this biomimetic alternative requires ultra-high-pressure directional freezing machinery that standard factories don't own. While wealthy nations can afford to retrofit their plants, developing countries face a massive financial barrier. This isn't a science issue anymore. It's a political and economic hurdle. But for the first time since the dawn of civilization, chopping down forests is no longer an absolute necessity. Would you live in a home built entirely from high-tech, compressed agricultural waste, Or does real timber have an irreplaceable soul science can't replicate? Let me know below.